אני מקווה שהיה לכם יום כיפי. We're going to be switching to English. Hi. So thank you everybody for joining me at this really late session. So at this point, yeah, woo! So it's 4:30. I don't trust myself to write code. I don't trust you to understand my code. So this session is going to be more of a philosophical, high-level session than really deep diving. And we're going to be discussing today the big picture, okay? So where is React going? My name is Ariel. I'm a full-stack engineer at Factify. I'm a mother of Ginger. This is Ginger, my dog. She's a back-end developer. I'm a public speaker at conferences, at meetups, and I love React. And I speak about React a lot, and for the past 2 years, I've been deeply investigating the whole concept of React server components and SSR. So this is going to be an opinionated talk, but I think I've earned it because from the amount of hours that I've invested on this topic. If I try to describe the current sentiment of the front-end industry, it would be this meme, okay? So all of the big libraries, React and Vue and Svelte and Angular, all of these have been developing SSR frameworks. But if you ask the average front-end developer, he doesn't understand why do we need SSR, what problems does it solve, and I'm not going to even start about the opinions about React server components. And what I'm going to try to do in this talk is to make my clicker work. So we're going to try to look at this from two perspectives. Okay, so the first perspective is the problem itself. What problem does SSR solve? Why do we need SSR? And the second angle of this is the solution. So React server components as the solution developed by the React team. So let's start with the problem. What problem does SSR solve? And in order to answer this question, I want us to look at a timeline. Okay, we're going to do a very short history class about the evolution of the web industry. So I'm looking specifically now at 2005 till 2021. We're going to go into what's happening next later on in this session. So since 2005, these 15 years have really shaped the web ecosystem and changed the way we write front-end code. From the original World Wide Web vision of a server serving HTML pages to a client and a client only running JavaScript for interactivity, we went the exact opposite direction of the intended, of what was intended. So 2005, okay, let's go over this quickly. We had Ajax, jQuery, a lot of things, and as you can see, like we're just getting more and more things. And it's just getting bigger. And when we look at this timeline, it helps us answer the question. And the thing is that to answer the question, we need to answer a different question. So to understand what problem SSR solves today, we want to answer what problem has client-side rendering solved at the time. So going from multi-page application to single-page application. Instead of sending an HTML per request, going to a single HTML that holds our entire application bundle. If we look at the point where client-side rendering was selected as our solution, okay, as our silver bullet, it happened in 2010. AngularJS was the first one to make this a standard. And when we look at the web ecosystem at that point in time, we didn't have a lot of tools. Okay? In 2005, we had Ajax, which enabled us to make asynchronous HTTP requests from the browser. Later on, we had jQuery, which was an imperative, declarative, depends how you look at it, library to update the DOM. V8, so JavaScript became a lot faster and a lot more efficient. And then that's when AngularJS came into the picture. And, whoa. Spoilers. So this was the web ecosystem before client-side rendering was the selected solution, right? We didn't have a lot of things in our hands. And I would like to look at everything that happened since we decided we're going full-on client. So the web ecosystem, since client-side rendering has become our silver bullet. All of these solutions kind of break down into 5 different categories. So the first is all of the developments in network. So HTTP 2 and 3 and 5G, so being able to send multiple HTTP requests over a single connection, going from TCP to UDP, 5G. Later on, we had language freedom, so being able to run JavaScript on a server, Node.js, which was the first JavaScript runtime. These days, the first out of many, with Bun and Dino coming in. And later on, we had WebAssembly. So now we are not even limited to only JavaScript. On our servers, we can run JavaScript, but we can also run binaries from completely different languages, from C, from Go, from Rust. This enabled a lot of other things. Later on, we had tooling, which is a very, very big effort still happening. So TypeScript, Babel, and later on, all of the new era of tooling, so Vite and ESBuild, which are all based on Rust and Go. And frameworks, so React is, as we know, a UI library. It doesn't define how do we build applications, how do we do data fetching, how do we do caching, how do we handle errors. And last but not least, distribution. It's kind of crazy to think that when at the era where client-side rendering was our solution, at the time we didn't have Docker, we didn't have Lambdas, Kubernetes, Cloudflare workers. That was a world where we didn't have all of these. Now, what am I trying to say, like besides teaching all of us the history of the web ecosystem? When we look at all of these things, what can we deduce? What changed? What changed is that these enable us to have a lot more code. We are dealing with a lot more code, like a lot more code, like so much more code, and we are constantly developing, and we are trapped in this vicious cycle that we are creating more code, so we need more tooling so we can handle all of this code, and then we create more code, and we need more tooling to manage it, and we're trapped. And you might be thinking, okay, why? We get it. We have a lot more code. The web ecosystem is evolving. But why does this mean that we need server-side rendering? What's the problem with client-side rendering? And to answer that, let's imagine we have a front-end team, okay? Where each developer in our front-end team builds a different component, okay? So let's say we have this cute team of 6 developers. But then the company becomes successful, right? So we actually recruit a lot more developers. So now we have like 5 different teams, and each single developer is writing and pushing more and more React code. And the company gets even more successful. It's been 5 years. We're raising a round C now, and we already have like 20 different front-end teams where each single developer is pushing more and more and more React code every day. And now, each developer has 10 different agents that are pushing more and more and more code. So when we look at all of these that are writing more and pushing more and more and more code, the harsh truth is that code bases just keep growing. Okay, code bases do not get smaller, code bases just get bigger. That is the way of nature, if you like. So still, why does this mean this is a problem? Why is client-side rendering a problem? Because we have a lot of people writing a lot of code. And for that, we want to discuss the nature of React. Okay, we are very, very used to the JSX abstraction. Right? Each developer builds his own component, and we're used to the abstraction of JSX. And when we use HTML tags in JSX, like a div, like a nav, it kind of feels like we're writing HTML, right? But we're not. This is an abstraction. Because the truth is that React is a really, really big recursive function. And JSX, even when we're writing a div or any HTML tag, is not really HTML. It's still more and more and more JavaScript. And this massive, massive recursive function is used to generate just this plain, very, very deeply nested object. So every time something changes, this whole recursion needs to run again. And this deeply nested object would be recalculated again and compared to the previous one. So still, where am I going with this? What is the problem? When you think about all of these people and machines pushing code to a huge recursive function that's supposed to run on a machine that you know nothing about, you have no idea about the machine where this is going to run. You might be running code on your M4 and everything is working really fine, but I suggest that you try my mother's old Lenovo. When I try my mother's old Lenovo on products that have been building front-end for over 10 years, usually I have latency in even opening a drop-down. And the reason is React's nature of being a really, really big recursive function. And the solution, well, this is a solved problem. Distribution. That's what backend developers did. That's what we will do too. This is a solved problem. So that's really where React Server components come into the picture. Okay, so React Server components are a bundler feature. Okay, it's a bundler feature developed by the React team and integrated in modern SSR frameworks. And what React Server components allows us to do, it allows us to distribute rendering between client and server or even multiple servers. And server-rendered components could be cached during build time and then later on served from a CDN, but they could also be rendered and streamed while we're rendering per request. So this is basically the React solution for the problem of this really, really big amount of JavaScript that needs to run on a machine that we have nothing about, okay? It's about distribution. That's the whole concept. Now, I want to focus on this architecture for a moment. So if we look at this architecture in a high level, we're kind of used to a lot of this, right? We're used to having a CDN serving us HTML. Like, we're used to that. And the change here is that now that instead of having a server that replies us with JSON, we have a server that has a JavaScript runtime and streams back parts of a React application. So instead of sending us JSON objects to be rendered on the client, we're already rendering on the server and streaming those components back. Now, I know you know all of this, but I would like to focus on this part of the architecture, because this is a really, really interesting part. Having a server that can stream parts of a React application is something that's getting more and more and more necessary every day. Why? Let's go back to our timeline, but let's make it accurate now. Let's go until the current day, so until 2025. So we know what is the new. We're living through a generation, a revolution, right? So all of the LLMs and agents and the way the web is going is changing as we speak. Okay? We are living through a revolution, and it's really hard to grasp when you're inside it. So all of the new LLMs, and specifically I want to discuss a new technology that's really, really new from the past year, which is the Model Context Protocol. The Model Context Protocol is a protocol that started off at Anthropic, but this has become the industry standard. And what the Model Context Protocol allows you is kind of to define APIs for agents. So when an agent needs to answer a question with accurate data, instead of having to homebrew everything in OpenAI or in Anthropic, me as my organization, I can create an MCP server that ChatGPT could do an API call to my server, and I can respond with my data. So let's just see how does this happen in action, and later on we'll see how does everything kind of connect. So let's say that we have a user that asks ChatGPT, what is the weather like in my area? For that, we would need to answer a few things, and we would need to get accurate data for it. The first thing is that we need to know what is the user's area. And later on, we would want to know, OK, after we know the user's area, we want to know what is the weather. So the way the architecture behind this looks kind of like this. We make this API call to the agent. And what the agent does is uses the model context protocol to use different tools. So we have a tool that only handles maps. So probably gets an IP and returns the city by the IP. So the agent is going to ask, what is the user's area? Where is the user located by his IP, for example? Later on, it's going to ask the weather tool, for example, OK, the user is in Tel Aviv. What is the weather like in Tel Aviv during this week? Now, what's interesting here is that because this is a standard protocol, we're not really limited to OpenAI's internal network. Okay? This means that the weather tool can also be an external tool. It can live outside of OpenAI's network, and this is what we know as connectors. So anybody using ChatGPT, when you can connect different connectors, this is what it means. It means that those companies have exposed MCP servers that can answer with their API. And there's a problem here, 2 problems. The first problem is the text approach. Okay? Humans like UI. If text was enough, this conference wouldn't exist. We wouldn't have front-end developers, we would just have CLIs, right? UIs are really, really critical for user experience. So that's the first problem, the text. The second problem is that this weather tool loses its brand. Okay? A brand has a character. It has a design system, it has colors, it has a logo. And when this tool only replies with a text, we kind of lose who this brand was. And the way to fix this is with a tool called MCP-UI. So MCP-UI is a new standard protocol just recognized by Anthropic. It was developed by 2 guys, one of them sitting in this audience. And what MCP-UI allows you to do is basically to answer ChatGPT. Instead of answering with only textual data, it allows you to answer with UI. Okay? So this way, the user also gets a good experience, but it's also good for marketing and branding reasons, so the brands can persist their brand identity. So how does this go together? It goes together because now we understand why the ability to have a server that can stream parts of a React application and to just stream UI elements instead is actually really, really critical. Okay? Instead of answering just text, we can just stream parts of the React application that maintain the brand's identity, the brand's design system, the brand's logo. Let's sum it all up. In this area that we're entering, we have 2 problems. The first problem is that we have a lot of code that we need to manage. And not all machines can run code that is developed by hundreds and thousands of developers and agents. The second problem is where it's not a problem, but it's kind of the revolution that we're entering. Most of the interactions, or at least Gartner says that 1/3 of the interactions within 3 years are only going to happen through agents and not through entering specific platforms for getting answers. I think we understand the problem, and I would like to say a few words about my opinion about the solution, or more correctly, the new problem. So I've been investigating React Server components really for a while, and I've been discussing a lot of really intelligent people over this topic. And the opinions I'm going to say here are my own, but I know a lot of other intelligent people hold the same opinions, if that makes it makes my credibility better. So, what problem has React Server components as a solution created? As we said, React Server components is a bundler feature. Okay? You write your code pretty much the same way. You add a few magic words, you put a use client here, you put a use server there, and this happens under the hood. You don't know, you're not in charge of what part of your code runs where. Like you're in charge, but it's really, really, really abstracted. And that is the problem. Magic shouldn't exist outside of Hogwarts. When you have something that's too magical, it's another word for saying this is a leaky abstraction. Because the truth behind what React is trying to do is that they're trying to abstract away the internet. Okay? They're trying to make you feel like you're still writing your nice little React app in the exact same way, and you add some magic words. But the truth is that developers have a really, really hard time doing a good job when things that are very, very critical are abstracted away from them. Because going over the wire has trade-offs. Content has to be serializable. You don't want to pass a lot of content, for example, over the wire. But when you're just passing props to a component, who would think that, these props need to be to a certain kilobyte size? Nobody would think about it because it's really, really abstracted. And I think that this is a very typical human story, that the attempt to make life too easy and to make React developers feel like they still have the same experience and they're still writing the same React code has actually made life really much harder. Because instead of having visibility over the boundaries, over where does my code run, at what point would it be generated, what is HTML, what would be streamed, when you abstract all of this, we have a really hard time to make intelligent trade-offs because we need to look for the boundaries instead of defining them. And I understand the initiative, and they didn't want to wreck our world, and they didn't want front-end developers to write server code, but we are writing server code. And it's even worse, because we don't know when we are writing the server code, and we just act like we're writing the normal React code that we always use to run. So to sum it all up, there is a real problem, okay? Client-side rendering doesn't scale. In our age, where a lot of developers keep pushing more and more and more code, it doesn't scale to run all of that enlarging code base on a machine that you don't know. And distribution is a necessary for solving this solution, for solving this problem. And especially in the AI area that we're entering, where we really need the ability to just stream parts of the React component in the architecture of the modern era, where you have an agent that just calls MCP tools. But the solution, in my opinion, is not... The intentions were good, but if you ask me, I think that it should have been a lot more explicit and less implicit, and we should have been able to define the server by ourselves, like other frameworks do these days. And again, all of the opinions that I've stated here are all my own, and I've been thinking about them for the past really 2 years now. So thank you, everybody, for listening at these hard times. If somebody wants to connect, that is my QR code, and if somebody has questions, find me later. Thank you.